They're the most mysterious, fascinating, and misunderstood creatures ever to walk the Earth. Now, get the real facts on these Jurassic giants in The Dinosaurs. The astounding 4-part PBS series is now available on home video from Turner Home Entertainment.
We have gained, finally, the first complete picture of what an early dinosaur looked like.
Follow some of the world's foremost paleontologists as they unravel the mysteries of these remarkable animals, from the mammal-like Myosaurus to the terrifying Tyrannosaurus Rex. When were the first fossils discovered? Where did they come from? And what caused the sudden demise of these giants?
I knew that if we were going to tell the story of the origin of dinosaurs, we had to come here.
There was a little more to evolution than Darwin realized.
In geological terms, their extinction was instantaneous.
The Dinosaurs takes you on a dazzling journey through the ages, featuring life-sized models, exciting animation, dynamic location footage, and such noted dinosaur experts as Dr. John Ostrom, the real-life inspiration for the main character in Michael Crichton's Jurassic Park. Epic, eye-catching animation and models, says the Philadelphia Inquirer. And the Los Angeles Times says, a compelling picture of what is known right now, with animation that may provide the first correct picture of how dinosaurs really behave. The Dinosaurs includes the most complete and up-to-date information that modern science can provide in The Monsters Emerge, Flesh on the Bones, The Nature of the Beast, and Death of the Dinosaur. The Dinosaurs is educational entertainment for the entire family. Get to know the awesome beasts who ruled the Earth for millions of years, only to disappear in the blink of an eye. The Dinosaurs is now available wherever video is sold from Turner Home Entertainment.
The following presentation is from PBS Home Video.
This is PBS.
Families of dinosaur species died out, no new species were formed, and they were gone.
There's an occasional really bad day when a huge rock falls out of the sky and makes terrible environmental disturbances.
The Dinosaurs is made possible by the Corporation for Public Broadcasting and the financial support of viewers like you.
For 160 million years, dinosaurs roamed the Earth, the most successful land animals ever. And then, 65 million years ago, in a matter of moments, geologically speaking, they disappeared. It is one of the greatest mysteries of science. What happened? Was it a catastrophic change in the Earth's climate? A sudden upsurge in volcanic activity? Disease? Or something else altogether? Over 200 years ago, George Cuvier established the concept of extinction. Mastodons and other animals such as saber-toothed tigers had gone extinct, he argued, and this idea paved the way for the study of even earlier plants and animals. The fossil record shows individual species of sea and land creatures disappearing at intervals of 5 million years or so. But from time to time, there appear to have been more dramatic mass extinctions when virtually all plant and animal groups lost at least some of their numbers, one at the end of the Triassic period, another at the end of the Jurassic, each of which opened the door to a new family of dinosaurs. And then at the end of the Cretaceous period, there came one final extinction that ended the reign of the dinosaurs for all time.
These mass extinctions are very special and very terrible events.
Paleontologist Bob Bacher.
It's not just one species going extinct. That happens all the time. But usually, you lose a species, a new one evolves, the whole family of species keeps on going. But right now with the great cats, most of the big species are extinct. We're not getting any new ones, and pretty soon all of the great cat family is gone. That's what hit the dinosaurs. The families of dinosaur species died out, no new species were formed, and they were gone. It was a horrendous geological crime. Who is exterminating the great species again and again and again? Let's look at some of the potential criminals.
One good suspect is the environment, a change in the climate of the planet. Throughout the age of the dinosaurs, the average temperature on the Earth was warmer than it is today. If the temperature had risen or fallen drastically, plant life would have withered, and animals, especially large animals, would have died out. Glaciers might have brought about that climatic change, the result of shifting continents and shifting winds. Perhaps ice built up at both poles, causing the winter to become incredibly cold, and dinosaurs, with no hair or feathers for insulation, couldn't sustain their internal temperature. Or perhaps the opposite happened. An explosion of volcanic activity that spewed red-hot volcanic dust into the atmosphere, blotting out the sun's rays. On this theory, dinosaurs would have had no warning of the approaching Holocaust. It would have all happened in a flash.
Or maybe the newest and sexiest theory has the answer. Maybe something out there from the cosmos smacked into the Earth, sending up a plume of dust, blotting out the sun's heat, and freezing the dinosaurs to death. Something huge, something full of energy, an asteroid.
The suggestion that an asteroid impact killed the dinosaurs dates from 1980. It came from a team of Berkeley scientists led by geologist Walter Alvarez.
Back in the 1970s, I was working in Italy with a group of other geologists and geophysicists on a project that had nothing to do with the dinosaurs. We were measuring, we were dating the reversals of the Earth's magnetic field that were recorded in a series of rocks that had been deposited on the floor of the ocean, one after the other like this, sort of made a book of Earth history. And while we were doing that work, we kept walking past this very intriguing layer of clay. And so I cut out a piece and brought it home. You can really see what's going on here. This layer is the top bed of the Cretaceous. This corresponds in time to the last times that the dinosaurs were alive. And this bed up in here is the first bed of the Tertiary, which is after the dinosaur extinction was over. And in between them is this layer of sort of red and green clay. And it seemed as if that had to be telling us something. So I cut out this piece of rock and brought it home, and not only was it interesting to me, I showed it to my father. It was interesting to him, too, and we decided, let's see if we can find out what is responsible for that clay.
Walter's late father, Nobel Prize-winning physicist Luis Alvarez, started by trying to date the clay layer to see how long it took to accumulate. What he found was the first clue to the impact theory. The clay was found to contain huge amounts of cosmic dust, specifically a platinum-like metal called iridium. Alvarez knew that while iridium is rare on the surface of the Earth, it is abundant in asteroids and comets. It was evidence, says Walter Alvarez, that a giant asteroid collided with the Earth.
What we finally came up with was the idea that dust and droplets of impact melt that had been thrown out of the atmosphere and dispersed all over the planet would make it so dark that photosynthesis would stop and the food chains would collapse and the extinctions would be the result of starvation when the food supply ran out.
Within hours of the impact, according to the Alvarez group, a great cloud of dust began to envelop the Earth. Beneath the cloud, day turned to a permanent night. The food supply dried up. Dinosaurs and millions of other creatures perished in the cold and the dark.
So what does it all mean? What does it tell us? It really tells us that there was a little more to evolution than Darwin realized. Darwin had it right, but he didn't have the whole story. Darwin said that in order for a species to survive and flourish and produce descendants, it had to be well adapted. It had to be very good at making a living in the normal world that it lived in. And what we're finding out now is, yes, that's true. That's absolutely true. But in addition, there's an occasional really bad day when a huge rock falls out of the sky and makes terrible environmental disturbances.
The idea that dinosaurs were the victims of a direct hit on planet Earth is chilling and enthralling. But is it true? Our investigation begins at Makoshika State Park in southern Montana. The rocks here are a record of the Earth as it was just before the dinosaurs disappeared.
We're going to line you up on the outcrops to do the survey, and you'll be about 10 or 15 feet apart, and you're going to walk slowly over the outcrops, looking for fossils. When you find
Diane Gabriel and David Fastovsky have brought these volunteers to Makoshika to count bones. With their help, they hope to settle a vexing question. Was the dinosaurs' demise sudden, as the impact hypothesis suggests, or did they die out gradually over the course of several million years?
So let's walk over that way.
There's never been a good answer to the question, because the number of dinosaurs alive at any given time has never been properly calculated. Here, Fastovsky and Gabriel decided to count every single bone.
Okay, everyone in position. Let's go. Remember to stay in line as much as possible.
They picked this site because the rocks here are filled with the bones from the very end of the dinosaurs' reign, the last 3 million years of the period of Earth history known as the Cretaceous. The boundary between the Cretaceous and the Tertiary period that followed is marked here by a blue band running through the rock. Above the boundary, there are no remains of dinosaurs to be found. But below it, they are everywhere. All you need is patience and a pair of eyes sharp enough to spot bone half buried in the rock.
Bone! We have bone, yes!
Okay, we'll be right there. We're on our way, Jackie.
Oh, it looks like a claw.
Oh, wow.
That's nice.
Wow. Oh, really nice.
Yeah, it looks like an ornithomimid to me. One of those ostrich-like dinosaurs.
Oh, yeah.
Yeah.
What'd you find?
We found an ornithomimid claw.
Well, that's terrific.
Real nice.
Well, what do you think?
Every find is meticulously recorded: type, position, and the kind of rock in which it is preserved.
Yeah.
Cross-stratified sandstone.
Yeah, medium grain cross.
For the past 3 years, Fastovsky and Gabriel and their colleagues have counted bones in the most complete dinosaur census ever taken. They've recorded 4,600 specimens from over 600 sites. Right up until the end of the Cretaceous, their evidence suggests, the dinosaurs were doing just fine.
The predominant animal that we found in our survey was Triceratops. The ceratopsians are really abundant at the end of the Cretaceous. And the next one would be the duck-billed dinosaurs, probably Edmontosaurus. And we found a lot of ornithomimids and animals like that. But we've also found lots of the small carnivores, the ones that scavenge and pick up after the other ones have killed them. And we do have Tyrannosaurus rex, too.
There doesn't seem to be any evidence for a gradual decline in their diversity. In fact, our study shows that in geological terms, their extinction was instantaneous.
Dinosaurian timescales are vast. In this context, instantaneous means 250,000 years. More evidence is needed to support the theory of an asteroid hit. For instance, how likely would it be? Once each month, for the few days when the moon is dark, Jean and Caroline Shoemaker come to Mount Palomar Observatory to find out. The Shoemakers are leaders in a relatively new field of astronomy. one they virtually invented, asteroid hunting.
When we started our program here in 1973, there were a dozen known Earth-crossing asteroids. They'd all been found accidentally over the course of some decades. And we began a systematic search then to look for more of them. At the present time, we know over 110 Earth-crossing asteroids have been sighted.
Picking asteroids out of the sky is slow work. The telescope is swung into position to photograph a precisely designated portion of the night sky. Each exposure requires several minutes of constant attention.
10, 11, 12, 13, 14, open. On 34 minutes, 15 seconds.
A second photograph, taken several hours later, is then lined up with the first. The result? The ghostly trace of an asteroid zooming between stars. This one was discovered by the Shoemakers in March 1989. It came within 500,000 miles of the Earth, less than twice the distance to the Moon. A near miss, but not an unusual one. The Shoemakers estimate that there are about 1,500 asteroids larger than 1 kilometer whose orbits cross that of the Earth. But Gene Shoemaker thinks something larger than an asteroid was responsible for the devastation 65 million years ago.
The objects that make really big craters, 100-kilometer diameter craters or 150-kilometer diameter craters that would produce a global catastrophe from the material that would be ejected and carried all around the Earth. Those objects are probably chiefly comets. My best estimate is that an object big enough to make a 150-kilometer crater, which would be about a 10-kilometer diameter comet, about the size of Halley's Comet, hits the Earth about once every 100 million years on the average.
Asteroid or comet, if a huge ball of rock fell out of the sky, surely more than dinosaurs would have been affected. Here in Zumaya, Spain, more evidence to consider. A group of sea animals, totally unrelated to dinosaurs, disappears from the fossil record at the exact moment of the dinosaur extinction. Dr. Peter Ward from the University of Washington in Seattle has come to Zumaya to conduct the kind of head count for sea animals that Fastovsky and Gabriel carried out with dinosaurs. What interests him are these once plentiful sea creatures, ammonites.
This is an ammonite fossil from these cliffs. If we could go back through time and find one of these alive, we would see that it's a swimming creature. Out of the front sat a series of tentacles, and much like the chambered nautilus does in today's oceans, it could swim around. During the Mesozoic, these creatures were fantastically abundant. There were 12,000 species of them, and although this is a small one, the largest of them were about 12 feet across. That would probably do you great damage were it to come up to you. These creatures are so abundant in the Cretaceous seas that were we to go back there, we would find that they occupied much of the place that fish do today. These are really the fish of the Cretaceous oceans.
Here in Zumaya, the boundary between the Cretaceous and the Tertiary is hidden in a depression running beneath the overhang of a cliff. Until recently, Peter Ward thought that ammonites died out well before the end of the Cretaceous. His latest research is revealing a different story.
The gully I'm sitting next to is composed of a clay layer, which is the boundary between the Cretaceous period and the Tertiary period. The rocks I'm sitting on are Cretaceous rocks. The limestones over my head are the first Tertiary rocks. Ammonites can be found in relatively common numbers within these rocks, and the last of them are found within inches of the boundary. It seems that the Ammonites at the end of the Cretaceous were thriving. They were producing new species, they were flourishing in their communities, and then suddenly, without warning, they disappeared.
When the dinosaurs vanished from land, life in the oceans suffered a similar catastrophe. Along with ammonites, whole populations of sea creatures, great and small, also disappeared. But could an asteroid produce such global devastation? This is Meteor Crater, Arizona. Nearly a mile wide, it is the result of the impact of a meteorite a mere 150 feet in diameter. For the Alvarez theory to work, the meteorite that wiped out the dinosaurs had to be 220 times larger. Let us suppose it was. What would its effect have been? Jay Melosh is a theorist who likes to imagine what happens when giant rocks fall out of the sky.
This is Kitt Peak National Observatory in Arizona, and I brought you here to give you a feeling for what the impact of a 6-mile diameter asteroid will do to the Earth. To get an idea of what 6 miles diameter really means, imagine the space between here and that distant peak on the horizon to be completely filled up with rock material. And further, imagine the space between the valley floor below us and an altitude of 6 miles filled up with solid rock. This enormous ball of rock will be rushing toward the Earth at 50,000 miles an hour, a speed that, if you were riding it, would take you from here to New York in under 3 minutes. When the asteroid strikes the ground, it buries itself in the Earth in a period of only 1 second. It opens a crater, a hemispherical hole in the ground that reaches a diameter of 30 miles about 10 seconds after the impact occurs. At that time, it's 15 miles deep. It's lined with red-hot rock debris streaming outward, forming a plume heading into the sky. At that time, the crater floor begins to rise back up. At the same time, the diameter of the crater continues to increase. It goes on until it reaches a diameter of about 100 miles before it stops growing. What happens next is really interesting. As the asteroid plunges into the ground, it creates pressures about equal to that of the Earth's core. Under those pressures, the asteroid and also some of the Earth rock melt and vaporize and expand back out of the crater as a plume or glowing cloud of very high velocity gas and dust. This cloud expands at velocities up to the Earth's escape velocity, sending the debris into ballistic orbits that eventually rain back all over the Earth. Trillions of tiny particles of this kind would fill the sky, radiating heat toward the ground. On the ground, you would feel an effect very similar to that of an oven on broil, lasting for about an hour. The even green vegetation would dry out and begin to burst into flame spontaneously as a result of this thermal irradiation, causing global forest fires.
There is evidence that this actually happened. Millions of microscopic carbon spheres have been found in the clay that was deposited at the end of the Cretaceous period. Soot from some enormous conflagration. And this clay layer has more surprises in store.
Gee, that's pretty neat. Yeah. It's right in the impact layer, yeah. Great.
At the U.S. Geological Survey, Denver, Glenn Izett and his colleague Fred Littke use a laser to analyze rocks from the Cretaceous-Tertiary boundary. The laser vaporizes the sample of the clay layer with in-point accuracy.
Here comes the Cretaceous sample. We'll load the last sample we did, the impact layer.
So the white spectra here is the Cretaceous marl.
That's right.
And that's superposed with the blue spectra here, which is the overlying impact layer. So where's the iridium, Fred?
Okay, the iridium. Let me show you here.
Iridium, rare on Earth but common in asteroids, is shot through the rock. In this sample from Colorado, the iridium is represented by the highest blue peak, and it is typical of hundreds of others found around the world.
We have two isotopes approximately in the right order for their natural abundance.
Izett finds that the clay also contains unusual, and he claims, significant grains of quartz. Viewed in polarized light, quartz usually appears featureless. This is the quartz from the boundary layer.
It shows these very peculiar lines through the quartz grain. They're oriented in this particular grain in this direction and this direction. These are called shock lamellae, and the only place that these have been found in rocks of the Earth's crust happen to be at high-yield nuclear explosion sites or at known meteor impact sites.
Iridium, soot, shocked quartz. All these pieces of evidence do point to an asteroid impact at the end of the Cretaceous. But if an asteroid did hit the Earth, where is the crater? It would have to be on an order of magnitude many times larger than the crater in Arizona. Glenn Penfield is a petroleum exploration geophysicist. In 1978, he was working in the Yucatan.
Muy buenos días, Capitán Boyle.
Buenos días,
Glenn
ingeniero.
Penfield.
Buenos días.
He was trying to find underground oil deposits for Pemex, the Mexican national oil company. In a series of aerial surveys, he measured faint variations in the Earth's magnetic fields. With luck, these would reveal oil-bearing structures beneath the surface. The work was straightforward enough. But as the survey progressed, something unexpected began to emerge.
From the beginning, when we first collected data from the aircraft, I began noticing a pattern of extraordinary symmetry in the magnetic anomalies. Later, we put these into a map, and the picture held up, one of a zone of highly magnetic material, an enormous ring of very intense magnetic anomalies that you can see here on the map, about 70 kilometers across. Very, very strong gradients in the field. Further out, a ring of very subtle features with a diameter of about 210 kilometers. A similar sort of configuration of anomalies is visible in the gravitational data. We see a central ring of high gravity anomalies indicating more dense material here in the center, again about 65 kilometers across, then a gravity low indicating lower density material, and finally another gravity high 180 kilometers in diameter. This area had been interpreted as containing volcanic features, but I had never seen volcanic features with this kind of symmetry on this sort of scale before. And it appeared to me that this had to be the result of a single event that at one time froze both the gravity and the magnetic fields in this highly symmetrical, highly ordered arrangement. And the most likely explanation to me was that of a gigantic meteor impact.
There was no doubt that Penfield had discovered something. A great circular structure 130 miles across, 2,500 feet beneath the surface of the Yucatan. In his mind's eye, Penfield saw a multi-ringed crater, complete with a raised central region and concentric rings. But where was the physical evidence in the form of actual rocks?
We lacked any samples to prove it. We had these excellent geophysical data sets, the magnetic and the gravity data, but not the physical samples which could establish once and for all that this was a gigantic impact feature.
In the 1950s, the oil company had drilled exploratory wells in 2 places in the Yucatan. Samples of rock had been taken from both sites. But when Penfield asked to see them, he was told they had all been lost or destroyed. In 1982, refusing to give up, Penfield went to the Yucatan to see if some rock samples had been left at the sites. First, he looked in the village of Sacapuk.
This is the Sacapuk #1 wellhead here in the middle of the village of Sacapuk. It was actually pretty easy to find. There were a lot more pigs when I was here a decade ago, and I dug both here and in the mud pit from the well that was drilled here, digging through quite a bit of pig manure that had been left for the last 30 years, in order to find the samples that might prove that this was an impact feature. This well was drilled to 1,500 meters. And for the first 1,000 meters, it was just a monotonous sequence of white limestone rock. And then the well site geologist reported a broken up kind of greenish material for a substantial thickness, and then finally something that looked like glass. Appeared to be a volcanic sort of glass, is the way it was described. And it was for a sample of either one of those 2 rocks, either this broken up greenish material or the glass, that I had come here.
The Sacapuk site yielded nothing useful, so Penfield went to the neighboring village of Chicxulub. There, on the grounds of a ruined estate, he found a second drill site.
Huh, interesante. Creo que sí. Chicxulub #1. Total depth 1,581 meters, 620.52. The final result of all my searching at Sacapuk and Chicxulub really amounted to very little. Oh. I had a few samples of cement matrix with some shards of rock in it that may or may not have come out of the wells. They weren't really amenable to any kind of analysis that would show that Chicxulub was an impact feature. And so, for the time being, I was completely stuck.
Penfield had come up empty. He wrote up his findings and went back to work looking for oil. In the meantime, the Alvarezes had proposed their asteroid theory. Now everyone was searching for the crater, but not in Mexico. This is the Brazos River in Texas. In 1987, Alan Hildebrand, then a PhD student at the University of Arizona, Tucson, had heard about the Alvarez impact theory and was conducting his own search for a likely crater. At the time, he had never heard of Glenn Penfield.
Today, the Brazos River here is about 200 miles from the Gulf Coast. 65 million years ago, the late Cretaceous sea covered this area. Here was about 500 feet deep. Along the banks of this river, we see the fossils of ammonites and other marine creatures that lived along with the dinosaurs and went extinct along with the dinosaurs at the end of the Cretaceous.
Hildebrand knew that hidden in the riverbanks is one of the world's most unusual Cretaceous tertiary boundary sites. In most places, the Cretaceous and Tertiary rocks are separated by a very narrow clay layer, one that is no more than a half-inch thick. But on the bank of this river, there is a rubble-filled interval almost 3 feet deep. Here, the dividing line between the world of the dinosaurs and the world that came after is startlingly clear.
This outcrop shows the Cretaceous-Tertiary boundary section. My feet are resting on the Cretaceous sediments. This is mud that was deposited in a sea that was about 500 feet deep. Here's the base of the Tertiary. From here upwards, we have sediments that represent a time when the dinosaurs were extinct. There's about 3 feet of sediment in between that indicates something extraordinary happened here. In particular, this lump of gray clay, which is a bit indistinct. You can see it goes around like so. This is a boulder about 3 feet across. Something happened that was able to uproot this gray clay from the Cretaceous seafloor and transport it and dump it here. Similar deposits of rubble like this occur all along the southern coast of North America at the Cretaceous-Tertiary boundary. The presence of the rubble beds here and the rubble beds all along the southern coast of North America indicates that something extraordinary happened here, something like a giant wave washing across the southern margin of the continent. We can't imagine how such a giant wave could have formed except for something like an impact in the ocean.
Still unaware of Penfield's work in the Yucatan, Hildebrand first suspected that a circular feature on the ocean floor off the coast of Colombia might be the crater. He was looking for the bruise left on the face of the Earth by a meteorite blow. Then he heard about another site, this one in Haiti. 65 million years ago, this region, like that around the Brazos River, was beneath the sea. High in the mountains, near the village of Balak in Haiti's southern peninsula, there was a curious sequence of marine rock. It was discovered by Florentine Maras, a native-born Haitian, now at Florida International University, Miami.
This is my site. That's the Belloc Formation. The bottom 2/3 from the valley is Cretaceous, and above it, that's Tertiary. Right about 1/3 from the road, you can see a little quarry, and that's where we have the KT boundary.
The KT boundary is what scientists call the layer of rock laid down at the end of the Cretaceous period. At first, Maras thought that he had found traces of an ancient volcano. Not until 15 years later did Alan Hildebrand suggest that, like the Brazos River site, it might indicate the presence of a nearby impact crater.
Okay, this is another piece of the boundary layer. As you can see here, it is very, very distinct. At the bottom, that's Cretaceous, and here that's the boundary, the so-called boundary layer. And we are going to take a sample to show you what it looks like.
It was at this point, September 1990, that the Dinosaurs series itself played a small part in the story. Samples collected for our purposes proved to be of particular interest to both Florentine Maras and geologist Glenn Izett.
Here's a sample of the rock that you see here being collected by Florentine Moras and that the Dinosaur production team was kind enough to bring back from Haiti. I've mounted the rock sample in plastic and then ground it flat so we can see what's going on with this in this rock. What really drew my attention is this zone here in the base of the sample, about 2 centimeters thick, of greenish black pellets.
Seen under the microscope, the pellets had a curious and distinctive shape. They resembled tektites, droplets of molten material splashed out of the earth by an impact and then frozen into form. A drop of milk falling into a bowl creates the same forms as it splashes into the liquid beneath. Tektites in the boundary layer would prove that an asteroid impact occurred at the end of the Cretaceous period. Izett took a closer look at the interior of the molten pellets.
It turns out to be a black glass, real tektite glass. It demonstrates that there really was an impact at the Cretaceous-Tertiary boundary. Tektites have only been found associated with large asteroid or comet impacts.
Meanwhile, Alan Hildebrand was still scouring the scientific literature, looking for word on circular features that would prove an impact once occurred. Finally, he came across Penfield's article on the Yucatan crater. In it, Penfield mentioned the lost samples of rock. But where were they? Hildebrand persisted in his search.
I wrote people, I called people, I talked to dozens of different people, and finally, with the help of colleagues, we got lucky, and I found that a set of samples have been sitting in New Orleans for the last 20 years.
In April 1990, Hildebrand passed the information along to Glenn Penfield, and Penfield paid a visit to the geology department at the University of New Orleans. After 12 years, his quest was almost over.
This is typical of the limestone rock present in the Yucatan No. 2 well.
The well that had been dug in Chicxulub. There were scores of samples produced as the drill chewed its way through 10,000 feet of the Earth's crust. They all looked pretty much alike, except for one.
This one here, from 301 to 303 meters, is unlike any of the others. Green, full of fragmented shards of broken up rocks that existed previously. It has a texture totally unlike any of the other samples of the limestone throughout the well. And it signifies a rock put together of fragments of pre-existing rock, disordered and jumbled together and broken up.
Penfield sent a sample to Alan Hildebrand to look for the key features that would signify the impact of a comet or asteroid, iridium or shocked quartz.
When Glenn Penfield sent me the first samples we'd found in New Orleans, we did a couple of separations of them, and we found some shocked quartz in both of the samples. And of course, with the duplication and the care we take in making these preparations, we were quite sure that we'd established that shock quartz occurred in this deposit outside but near the crater. So likely the big hole nearby was a crater.
Millions of years ago, something happened here. A titanic explosion that sent shock waves hundreds of miles in every direction, carrying debris at least as far as the coast of Texas.
We're sitting here at ground zero in the Chicxulub crater. It stretches for 90 kilometers in every direction around us and represents one of the most cataclysmatic events in the Earth's history. We named it Chicxulub, both for the village nearby here and for the first well that was drilled into the structure, but also appropriately because Chicxulub in the ancient Mayan dialect means the tail of the devil.
The Yucatan crater is in the right place, and it's the right size. But is it the right answer? Perhaps the dinosaurs were already going extinct. Scientists know that 61 kinds of dinosaur were alive 6 million years before the end of the Cretaceous. But 2 million years before the end of the Cretaceous, there were only 18. Recently, new evidence has come to light that something did indeed hit the Earth in the late Cretaceous period. Most paleontologists are reluctant to accept the idea that this event could have extinguished the dinosaurs.
Okay, the asteroid theory. Does it explain the extinction of dinosaurs? There are problems. There is the frog problem. You see, there are thousands of species of tropical frog today, and frogs are immortal as family of species. They never suffer mass extinction. When the mammoths went extinct, the frogs survived. When the dinosaurs went extinct, the frogs survived. And frogs are very delicate animals, very delicate to climate change. If you smacked the Earth today with an asteroid, blotted out the sun, you would freeze frogs long before you'd freeze a big animal. What kills off big animals like dinosaurs or elephants? What does an elephant do that a frog doesn't? Elephants spread.
Dr. Bacher points out that large land animals, such as elephants, travel enormous distances in the course of their lives. In this sense, dinosaurs resemble today's fast-moving beasts, capable of traversing large expanses of terrain. And towards the end of the Cretaceous period, dinosaurs do seem to have gone traveling in large numbers. Newly formed land bridges connected previously isolated continents and made it possible for dinosaurs, if they wished, to walk from Mongolia to Montana. This brought different species of dinosaur into contact with one another for the first time, which leads to the theory of dinosaur extinction favored by Dr. Bacher. Bacher points out that in the late 19th century, the disease rinderpest spread from Asia to Africa, threatening the extinction of nearly 40 species of African antelope. In the same way, he argues, when dinosaurs crossed the land bridges, they were exposed to new strains of disease that could have wreaked havoc among dinosaur populations. Like the colonists who brought measles to the Americas, when dinosaurs spread, they spread disease and became in turn the victims of their own relentless exploration. What caused the dinosaurs to vanish from the Earth? No one knows for sure. There is no agreement on a most likely answer. But what we do know, as a result of the surge in dinosaur studies over the last 40 years, is that the old picture of dinosaurs was wrong. These were not sluggish, small-brained blimps. They were gloriously varied creatures, some striding boldly along on 4 legs, others skimming the ground on 2. Some were hot-blooded, many were gregarious and social. They traveled far and wide, armed and ready to do battle for food or to die in defense of their young. Tyrannosaurus rex, Iguanodon, Brontosaurus, Deinonychus, Stegosaurus. Though long dead and buried, they still roam free in the forests of our imaginations. And more of their kind wait still, frozen in stone, to enthrall those who come after us, children and scientists alike.
Okay, so the dinosaurs went extinct. Things like Allosaurus and all its giant kin died out. Is that a tragedy for everybody? Well, no. If you were small, you survived. And if you were small and furry and had a twitchy nose and beady eyes like this chap, you could evolve into a wonderful range of big mammal families. You could evolve into moose, you could evolve into aardvarks, into warthogs, into apes, into humans. So from an ancestor like this came people. Humankind owes its success story to the extinction of giant dinosaurs.
The Dinosaurs was made possible by the Corporation for Public Broadcasting and the financial support of viewers like you.
As an additional service of this station, the Dinosaurs series is available from PBS Home Video. To order by credit card, call 1-800-PLAY-PBS.
This is PBS.